Hello students, welcome to Automotive Common Design. We are in model 2. In the second module, first we have solved several problems based on design of shafts. Now we have started design of bearings. Okay. In the previous class we have solved two problems based on dynamic load condition. So today also we are going to continue the same topic, dynamic load conditions, but varying load like cycling load. Okay. Cycling load means initially if there is a shaft and shaft is rotating, for first few minutes there will be 1000 Newton load, and then next few hours then 2000 Newton load will be there, then next to the few hours 500 Newton load will be there. So like this, the load which is applied on the shaft or applied on the bearing will be changed based on the time. Okay, so that is called cyclic load. Okay, suppose if they given cyclic load means same formula only we are going to use, C equal to P into L10 1 by 3, but this P value, okay, this dynamic load, okay, instead of P we have to put PE. Instead of P we have to put PE. PE means equivalent load. Okay, so like initially the shaft might have rotated at 500 RPM speed and 10 kilonewton load. Then later speed might be changed after a few minutes. Speed might be changed as 700 RPM and load will be changed as 15 kilonewton load. Like this, they might change speed and load. So suppose if they change speed and load means we have to write it inside the root, okay, cubic root, and we have to divide it by summation of the speed. Okay, suppose 4 speed they have given means N1 plus N2 plus N3 plus N4. Here N1 P1 cube, N2 P2 cube, N3 P3 cube, N4 P4 cube. Like that we have to put. Okay, so this is called equivalent load. PE means equivalent load. Right. We will solve one problem. A single row deep groove ball bearing has a dynamic load capacity of 40,500 Newton and operates on the following work cycle. Radial load of 5,000 Newton at 500 RPM for 25% of the time. Then radial load of 10,000 Newton at 700 RPM for 50% of the time. Then radial load of 7,000 Newton at 400 RPM for the remaining 25% of the time. Suppose if it is rotating for 1 minute means first 15 minutes it will rotate at 500 RPM. Then next 30 minutes it will rotate at 700 RPM. Then next 15 minutes it will rotate at 400 RPM. Suppose if it is rotating for 1 hour means it will be divided like this, 25%. In 1 hour 25%, 15 minutes. In 1 hour 50%, 30 minutes. In 1 hour 25%, again 15 minutes. Like this time will be divided. Okay. And we have to calculate the expected life of the bearing in hours. That is L10H. L10H value we have to find out. So in the question itself they are given C value, dynamic load capacity. C value is 40,500 Newton. Your C value they are given. Right. Now draw a tabular column. Draw a tabular column. In the tabulation, first column is element number. Suppose three speeds they are given means here we have to write 3 speeds. 4 means number 4. Suppose 5 variations, number 5 up to 5 like this. Okay. Then here second column is load. Okay. Third column is time. How much percentage of time. Fourth column is speed. Then we have to multiply the speed with the percentage of time. Okay. So first element, first 5000 speed for 25% of the time, and at that time speed is 500 RPM. Next 10,000 Newton load 50% of the time, and at that time speed is 700 RPM. Next 7,000 Newton load for 25% of the time, and at that time speed value is 400. Okay. Now multiply the, see first add this all the timing. Okay. If you add the time you will get the answer as 1. You have to get the answer as 1. If you add the time you will get the answer as 1. Okay. Then you multiply the time with the speed and write it here. Okay. Time with the speed. Multiply and write it here. 0.25 500 125, 0.5 700 350, 0.25 into 400 100. Like this you would write. Okay, right. Now we have to substitute the value. Okay, now we have to substitute the value. N1 means this speed. We have multiplied, no, that speed we have to take. This speed. Write it here. P1 means this particular load. Like this, substitute everything and fill it. Now add all the speeds add. Yeah, if you add all the speeds means 575 is the answer. Substitute everything and we are getting equivalent load as 8860. That is 8860 as answer. Now in the question they are given C value. Now we got PE value. Substitute everything inside the formula. Actually the formula is C will be equal to PE into, see this is the formula. C will be equal to PE into L10 power 1 by 3. Okay, power 1 by 3. If it is rolling bearing means 1 by 3, I think so. Yeah, rolling bearing means 1 by 3. But C will be equal to P into L into 10 power 1 by 3. Now I know C value. I got P value. Okay, what I need? I need L10 power 1 by 3. Now bring this P down. So C by P. Here we have L10 power 1 by 3. If the power is shifted to another side of the equal means it will be converted into power 3. Okay, that's what they have given here. Same formula they have rewritten it. Same formula has been rewritten. So here substitute all the values. You are getting the answer as 95.51 million revolution. 95.51 million revolution. Now we need in terms of hour. In terms of hour we need the answer. So L10H equal to L10 into 10 power 6 divided by 60N. They are given the speed value. So the final answer is 2768.45 hours. 2768.45 hours. Very simple problem. We will solve one more problem. This problem has been given in the model question paper. Okay, a shaft rotating at a constant speed is subjected to variable load. The bearings supporting the shaft are subjected to stationary equivalent radial load of 3 kN for 10% of time, 2 kN for 20% of time, 1 kN for 30% of the time, and no load for remaining time of cycle. If the total life expected for the bearing is 20 into 10 power 6 revolution, 20 million revolution at 95% of the reliability. Calculate the dynamic load rating of the ball bearing. Okay, write down the given data. 20 million revolution, P1 3 kN, P2 2 kN, P3 1 kN. Draw the tabulation. Element number, load, element time, speed, revolution in element time. For first element, load is 3 into 10 power 3. Element time is 10%. Okay, 10%. 10% means 0.1. Speed, they didn't give the speed value. So let me take the speed values n. And in the question, they told constant speed. Only load is varying. Speed is same, constant speed. Okay, va? So speed is n here. Okay, va? Now next load 2 into 10 power 3 for that time 20% of the time. 20% means 0.2. Same speed n into 0.2 n. Next 1 kilonewton 1 into 10 power 3 30% of the time, so 0.3. Speed is same, 0.3 into n. Okay, last one, no load. Okay, I couldn't bring the red down. After this I couldn't bring it. Okay, see the fourth one. In number 4 there is no load on 4 and the timing is remaining timing 10% for first load, 20% for second load, 30% for third load. So remaining 40% of the time. 40% of the time there is no load. And speed is same speed n. Okay, 0.4 into n. So if I add all the element minute means I am getting 1 as answer. If I add everything means I am getting 1 as answer. Here if I add everything means I am getting the speed as capital N. Okay, because it is rotating in constant speed, no, that's why I am getting the total speed value as N. Okay, next, what we have to find? We have to find out load bearing capacity. Okay, C value we have to find out. C equal to P into L10 power 1 by 3. Okay, rolling bearing, so power 1 by 3. So P we have to find out first. P equal to cubical root of N1 P1 cube plus N2 P2 cube, N3 P3 cube, N4 P4 cube divided by N1 plus N2 plus N3 plus N4. So if I add all the N1, N2, N3, N4 value means, see the tabulation. If I add all the values, I am getting the answer as capital N. So that's what I have substituted here, capital N. Next, here P1 value is 2.7. Okay, 2.7 into 10 power 3. Sorry, 0.3 into 10 power 3. P1 value is 0.3 into 10 power 3. If I multiply, really sorry. P1 value is 3 into 10 power 3. 3 into 10 power 3. Substitute 3 into 10 power 3 here. Substitute 3 into 10 power 3 power 3. 3 into 10 power 3 whole power 3. 3 into 10 power 3 whole power 3. So 3 power 3 answer is 27. Okay. So then 10 power 3. Okay. And then N1. N1 is 0.1 N. So if I multiply means I am getting the answer as 2.7 into. So I have substituted all the values and I have multiplied and I have written here. N1 P1 cube I have substituted here. N1 P1 cube I have substituted here. Answer is 2.7 into 10 power 9 into 1. Similarly, N2 P2 cube, substitute the value here. You will get the answer as 1.6 into 10 power 9 into n. Then N3 P3 cube, substitute the value. You will get the answer as 0.3 into 10 power 9 into n. Finally, N4 P4 cube. N4 value is 0. If you substitute, it will be cancelled. This term will be cancelled. See, in everything, n is common. In all the term, n is common, 10 power 9 is common. So if we take the n out means n in the denominator and n in the numerator will be cancelled with each other. See, it will be cancelled with each other. Then 10 power 9. 10 power 9 is common all the times. If I take the 10 power 9 out of the cubical root means 10 power 9 will become 10 power 3. Okay, in the last line that's what I have written. 10 power 9 is common in all the terms. So take 10 power 9 out. If you take 10 power 9 out of the cubical root means 10 power 9 cubic root means answer will be 10 power 3. Okay, that's what I have written in the last line. Then 2.7 plus 1.6 plus 0.3. If you add means you will get 4.6 as answer. If you take the root means you will get 1.663. Cubical root means you will get 1.663 into 10 power 3 Newton as answer. Now we have to find out C value. C value equal to PE into L10 power 1 by 3. PE value is 1.663 into 10 power 3. L10 value is 20 million revolution. 20 million revolution. I should not put the million value here. See, initially I put million value here. But you should not put million value here. You just write 20. That's all. Because we have to put the term in term of million revolution only. Not simply revolution. 20 million revolution. So just put 20 here. Cubic root of 20 is 2.7. Okay, cubic root of 20 is 2.7. Actually, this 100 will not come. Okay, if you take cubic root for 10 power 6, 100 will be answer. But you should not put 10 power 6. Wrongly, I have placed 10 power 6 inside. So remove it. 100 also will not come. This is wrong. 100 will not come. And here the power will be, if you multiply 1.663 with the 2.7, you will get the answer as 4.49 into 10 power 3. 4.49 into 10 power 3, not 10 power 5. This is wrong. Okay. 4.49 into 10 power 3. See, here we should not put 10 power 6. Remove this 10 power 6. Wrongly I placed inside. Here also remove this 100. 100 will not come here. Here 10 power 3 will be coming. 4.490 into 10 power 3. Final answer is 4.490 Newton. this last 10 you have to delete it. Okay, 10 will not come. 4490 Newton is the answer. 4490 is the answer, loading capacity. So this is very simple, easily you can solve this problem. Only one formula, this formula only. Okay. We will solve one more complicated problem based on bearing in the next class.